Let's begin this analysis with a statement that might hurt the purists. The internal combustion engine, for the vast majority of its existence, has been a failure. Since Nicholas Otto fired his first four-stroke engine in 1876, engineers have been fighting a losing battle against the laws of thermodynamics. The physics are cruel. In a standard petrol engine, the vast majority of the energy contained in the fuel does not move the car. It is lost. For decades, the industry accepted a rule of thirds. 1/3 of the energy goes out the exhaust pipe as hot gas. 1/3 is absorbed by the cooling system to keep the metal from melting, and only 1/3 pushes the piston down. This means that for 100 years, we have been driving machines that are roughly 30% efficient. In the early 2000s, Toyota launched a crusade to break this limit with the Prius. They refined the Atkinson cycle, they polished the internals, they clawed their way to 38%, then 40%, and finally 41% thermal efficiency. The automotive world declared this the physical ceiling. They told us that pushing beyond 40% in a road-legal car would require materials so expensive and tolerances so tight that it was commercially impossible. They lied. While Europe was drafting legislation to ban the engine, BYD engineers in China were dissecting it. They weren't interested in making it sporty. They were interested in mathematical perfection. The result of this obsession is the DMI 5.0 powertrain. It achieves a certified thermal efficiency of 46.06%. This number is not just a statistic. It represents a fundamental shift in how we convert chemical energy into kinetic energy. It allows for a real-world range of 2,100 kilometers. Today, we are going to ignore the marketing. We are going to perform a deep dive engineering breakdown of the 7 technologies that allowed BYD to break the thermodynamic ceiling. To understand the magnitude of this engineering feat, we must start inside the combustion chamber. The single most important number in this engine is 16.1. This is the compression ratio. In the world of thermodynamics, compression is king. The more you squeeze the air-fuel mixture before igniting it, the more energy you extract when it expands. It is a linear relationship. However, there is a limit. It is called auto-ignition or knock. If you squeeze petrol too hard, the heat generated by the pressure causes the fuel to explode spontaneously before the spark plug fires. This explosion tries to push the piston down while it is still moving up. It is like hitting the engine with a sledgehammer. It destroys connecting rods and melts pistons. A Formula 1 engine runs at roughly 13.1 to 14.11. A Ferrari 458 runs at 12.51 in 1. The BYD Xiaoyun engine runs at 16.1. How is this possible on 92-octane pump gas? The answer lies in the radical application of the Miller cycle. In a standard engine, the Otto cycle, the intake valve closes exactly when the piston reaches the bottom of the cylinder. Then, compression begins. In the BYD engine, the intake valve stays open. It refuses to close. As the piston begins its upward journey to compress the air, the valve is still wide open. This physically pushes a significant portion of the air-fuel mixture back out of the cylinder and into the intake manifold. This sounds counterintuitive. Why throw air away? Because it decouples the compression ratio from the expansion ratio. By rejecting some air, the effective compression ratio is lowered to a safe level, preventing the bomb from going off. But, and here is the genius, the expansion ratio remains at the full 16.1. When the spark fires and the piston is pushed down, it travels the entire length of the long stroke cylinder. This allows the hot gases to expand until they are almost at atmospheric pressure. They extract every single joule of work. In a normal car, when the exhaust valve opens, there is still high pressure inside. The ash pops somewhat one point found. In this engine, the energy is used up. The sponge is squeezed dry. But simply using the Miller cycle creates a new problem: lack of power. By throwing air back out, you lose density. and at 16.1 the flame propagation can be unstable. You need the mixture to burn instantly. If the flame moves slowly across the cylinder, heat has time to transfer into the aluminum walls. That heat is lost energy. You need a flash fire. BYD solved this with high tumble aerodynamics in traditional performance engines. Engineers polish the intake ports to make the air flow straight and smooth. BYD did the opposite. They designed the intake port with a sharp, calculated angle that forces the incoming air to trip as it enters the cylinder. This creates a violent, vertical vortex, a tumble. Imagine a tornado inside the cylinder. This turbulence mixes the petrol molecules with the oxygen molecules at a microscopic level. It creates a perfectly homogeneous mixture. So, when the spark plug fires, the flame doesn't just spread from point A to point B, it consumes the entire chamber almost simultaneously. This rapid combustion is critical. It ensures that the heat energy pushes the piston down before it can be absorbed by the engine block. It turns chemical energy into mechanical force faster than the laws of thermal conductivity can steal it. There is another enemy to efficiency at 16.1 compression: heat. Even with the Miller cycle, the temperatures inside the cylinder are close to the melting point of aluminum. This creates nitrogen oxides, a NOx, a pollutant, and risks thermal failure. To solve this, BYD implements a massive cooled EGR system. EGR stands for exhaust gas recirculation. Most cars use a little bit of EGR to reduce emissions. BYD uses it as a core combustion component. They take the exhaust gas, which is inert and cannot burn, and pass it through a dedicated, high-capacity water-cooled heat exchanger. It's essentially a refrigerator for smoke. They then pump this freezing cold, oily, inert gas back into the combustion chamber. Why? Because this gas acts as a thermal sponge. It sits inside the cylinder during the explosion. It doesn't burn, but it absorbs the peak heat spikes of the combustion. It smooths out the thermal curve. It allows the engine to run at optimum ignition timing without melting the pistons. It allows them to run a lean burn, see and no burn strategy that would destroy a normal engine. It is a chemical hack that allows a street car to run race car compression ratios. Now, let's move outside the cylinder block. If you look at a traditional engine, it is covered in parasites. A standard engine has a heavy steel crankshaft. Attached to the front of that shaft is a pulley. That pulley spins a rubber belt. That belt spins an alternator, a water pump, an AC compressor, and a power steering pump. Every single one of these components is a thief. They steal 5, 8, maybe 10 horsepower from the engine just to exist. They add drag, they add friction, they add weight. BYD's philosophy for the DMI 5.0 was engineering by subtraction. They asked, why does the engine need to power the air conditioner? The answer, it doesn't. This is the world's first mass-produced feedless engine. Front-end accessory driveless. There are no belts. There are no pulleys. There are no tensioners. The alternator, gone. The main traction motor charges the battery. The starter motor, gone. The generator motor starts the engine instantly and silently. The AC compressor, high voltage electric. It runs off the battery. This means you can have ice-cold AC even when the engine is off. The water pump, electric. In a normal car, the water pump spins fast when the engine spins fast. That is inefficient. You don't need high water flow just because you are revving high. In the DMI, the water pump is PWM controlled. It spins exactly as fast as the thermal management computer tells it to. By stripping the engine naked, BYD ensured that 100% of the energy produced by the pistons goes to the generator. There are no parasites left to feed. Efficiency is often lost in the invisible gaps between metal parts. This is the science of tribology, the study of friction and lubrication. In a standard engine, you have a single thermostat. It keeps the whole engine, head and block, at roughly 90 degrees Celsius. This is a compromise. It is lazy engineering. BYD implemented a split cooling system. They realized that different parts of the engine want different temperatures. The cylinder head needs to be cold, around 80 degrees, to prevent detonation and keep the valves happy. But the cylinder block needs to be hot, around 105 degrees Celsius. Why? Because of the oil. Modern 0-20 oil behaves differently at different temperatures. If the oil is too cool, it is thick and viscous. It creates hydrodynamic drag on the piston skirts and the crankshaft bearings. It resists movement. By deliberately keeping the engine block hot, BYD keeps the oil in its absolute lowest viscosity state. It becomes as thin as water. The pistons slide with almost zero resistance. Furthermore, they eliminated the heavy cast iron liners that are usually pressed into the aluminum block. Instead, they use a plasma sprayed coating, similar to the technology used in the Nissan GT-R. This coating is microscopic, ultra hard, and mirror smooth. It reduces friction by another 15%. Every micron of resistance was hunted down and eliminated. Now we must address the transmission. This is where the Japanese lost the war. Toyota relies on the planetary gear set, ECVT. It is reliable, but it involves metal gears grinding against each other. Friction, noise, loss. Volkswagen relies on the DSG, dual clutch. Heavy, complex, maintenance heavy. BYD asked a dangerous question. Why do we need a transmission at all? The answer? We don't. The DMI 5.0 uses the EHS, electric hybrid system, for 90% of your driving life. City commuting, traffic jams, suburban drivings, and even hard acceleration. The petrol engine is physically disconnected from the wheels. There is no drive shaft. The engine is just a dedicated power station in the background. Because it doesn't have to drive the wheels, it doesn't have to deal with transient loads. It can sit at its perfect sweet spot RPM, around 2200 RPM, where it is most efficient, and stay there. The wheels are driven by a massive 160 kW electric motor. This gives the car the driving characteristics of a pure EV. Instant torque, zero lag, no gear shifts. But here is the genius part, the highway clutch. Electric motors have a weakness, high speed. Above 70 mph, electric motors become inefficient. So, when the DMI hits highway speeds, a single hydraulic wet clutch locks the engine directly to the wheels. It is a direct link, a 1.1 ratio, no gears, no losses. It is the perfect overdrive. And crucially, BYD revolutionized the cooling here too. Previous electric motors were cooled by water jackets on the outside. The EHS uses direct oil spray cooling. They pump dielectric oil directly onto the copper, hairpin windings inside the motor. It is like taking a shower in coolant. This increases heat dissipation by 30%, allowing the motor to run harder and cooler than anything from Germany. Finally, we look at the obsession with detail, the lead-acid battery. That heavy, toxic brick that sits in every car. It weighs 15 kg. It dies every 3 years. It contains lead and sulfuric acid. It is 19th century technology. BYD threw it in the trash. The DMI 5.0 uses a tiny 2-key lithium iron phosphate 12V battery. It lasts the life of the car. It has its own brain, BMS. Crucially, if you leave your car at the airport for 3 months and the 12V battery dies, the main traction battery wakes up and recharges it automatically. You will never be stranded with a dead battery again. And what about winter? Traditional hybrids freeze. Their batteries lose power in the cold. BYD invented pulse heating. Instead of using an external heater that drains the battery, the system vibrates the high-frequency currents inside the battery cells. This molecular vibration creates heat from the inside out. It's like a microwave for the electrons. It ensures that even in minus 20 degrees Celsius, the car performs with 46% efficiency. It heats the battery without wasting energy heating the air around it. The new reality. So, What does all this mean? The BYD DMI 5.0 is not just an engine, it is a philosophy. It proves that the limits of physics were just limits of imagination. By removing the belts, removing the gearbox, and controlling the explosion with software, they have created a machine that makes the internal combustion engine relevant for another 50 years. But not as a master, as a servant. The engine is no longer the star of the show. It is the silent partner. The era of the roaring, inefficient engine is over. The era of the silent 100 km surgical instrument has begun, and Toyota has a lot of work to do.